Building artificial intelligence is an attempt to mimic the human brain. To replicate that complexity, you need a 12-month progression of foundational skills. The starting point for this journey is Python. It is the standard language across the industry, but memorizing loops and dictionaries is insufficient. Coding syntax requires foundational logic to be effective. This diagram shows the specific mathematical focus required for AI. Success depends on statistical and domain intuition rather than manual calculus. If you can understand the visual difference between correlation and covariance on a graph, you have the skills to proceed. These first few months focus on building the mathematical and programming lenses required to analyze raw data. This visualization shows the pipeline for handling real data. Python uses 4 specific libraries to process large datasets. First, you run the raw data through NumPy and Pandas for structural analysis. Then, you pass that sorted data into Matplotlib and Seaborn to plot the information visually. Once your data is clean, you reach the first major machine learning milestone. On the left is supervised learning, where you train a model to predict known outcomes based on historical labels. On the right is unsupervised learning, which finds patterns in raw data without pre-existing labels. To start making predictions, you need to master 3 baseline algorithms: linear regression for continuous numbers, logistics regression for binary categories, and naive Bayes for probability-based sorting. Your first major project checkpoint applies these algorithms to historical passenger data from the Titanic. You will clean this dataset and build a model to predict survival rates, testing your results against a global standard on Kaggle. Let's test what we've covered so far. Pause the video and answer this. If you have a messy Excel file of house prices, which 2 Python libraries do you use to clean the data? And which beginner algorithm do you use to predict the future price? Connecting theoretical code to raw data is how you move past basic tutorials. Completing these steps proves you can handle the requirements of a real-world dataset. This diagram illustrates how to improve prediction accuracy in Semester 2. A single decision tree often fails to capture complex data points. To fix this, you apply ensemble learning, combining multiple models into a forest that averages errors to produce a single prediction. From there, you move into deep learning. Artificial neural networks process information through hidden layers of nodes, modeled after biological data processing. After mastering basic neural networks, the curriculum branches into specific senses. Convolutional neural networks allow a computer to process and classify visual images. For textual data, you must learn natural language processing. This involves converting words into numerical data using algorithms like TF-IDF or Word2Vec. Mastering deep learning moves you beyond simple spreadsheet analysis and into building systems that process unstructured visual and textual data. A model isolated on a local Jupyter notebook provides no real-world value. This gap between training and deployment is where many beginners stop learning. This diagram shows the final step, getting your model online. You will use Git for version control and a REST API framework like Flask to host your model. Zooming out, this chart shows the complete 12-month roadmap. Semester 1 builds the foundation with Python, statistics, and baseline machine learning. Semester 2 scales that complexity through neural networks, ending with deployment. Take a screenshot of this master plan to track your progress. We are releasing tutorials for every node on this map, so subscribe to the channel to follow the curriculum. AI mastery is the ability to build an unbroken, functional pipeline that transforms raw data into a globally accessible service.